Hi, this is Miss Webb. This video is on graphing linear inequalities. And this is like my fourth take, so I don't care what happens in this one. This is it. I've had my phone ring. I've had everything. Here we go. Okay, I wanted you to go back and remember that originally when we graphed inequalities, we did it on a number line. Okay, let me go get my pen. Okay, so back in the first semester, if I had to graph x is less than 1, I would put in a number line. Go plot 1. Since it's less than, I'd put an open circle because 1 is not included. And I had to know, okay, what area of the number line it's going to take from 1 all the way down here to negative infinity. That's what makes that true. When we hop to the coordinate plane, it's very similar. If I look at, I'm going to go look where x is equal to 1, which would be right here, everywhere right here. And this time, I'm going to talk about a region. So I would graph that exact same inequality. I would do it like this. That's how I graph it on the coordinate plane. Okay, what's important to remember is a linear inequality describes a region. Okay, and I'll go back to my pen. It's a region of the coordinate plane. Here we go, a region. And the line is the boundary line. So if the boundary line is solid, that means it's included. But if it's dashed, you can think it's not included. Okay, and on these, I would want to do a region. And I could pick, let's see which one I want to get. It's got white. I don't want it to be white. I want it to be yellow. I'm going to do an entire region on one side or the other of the line. Over here, it might be over here. Okay. What's important to know is that any coordinate point that I pick, if I pick a coordinate point right there, that point, 0, 0, would make the inequality true. Over here, since 0, 0 is shaded, that point would make the inequality true. Any point, -3, 2, that point would make the inequality true. Okay, I have some steps. The first thing I do is I decide if the line is solid or dashed. And I have down here if it's less than or greater than, it's dashed. It's not included. If it's less than or equal to or greater than or equal to, it's a solid line. And what we're going to do is we're going to treat the inequality as an equal sign and we're going to graph the line. We're not going to worry about it. Okay, but when I graph the line, I like to know whether it's dashed or solid ahead of time. Then we're going to select a point with the original equation on either side of the line to determine which region to shade. So let's do some examples. Step 1, it's a less than, so I'm going to determine that it's dotted or dashed. And I am going to graph the line y equals -4x minus 1. It happens to be in slope-intercept form, so I'm pretty happy because I immediately can just look at it and tell you that the slope is equal to -4 over 1. It's the coefficient in front of x. And I know the y-intercept is equal to -1. That means there's a point that if I put a 0 in for x, y is -1. So again, you have to remember how to graph lines. I go to point 0, -1. There's my y-intercept. And I have the slope as -4, 1, which means I'm going to go down 4, 1, 2, 3, 4, to the right 1 because it's a positive 1. Or I could say that that's equal to 4 over -1. And I could start here and go up 4, 1, 2, 3, 4. And then I would go left because it's negative to -1. And now I'm going to make my little dotted line here. All the way down here. Okay, I got my boundary line. Now I want to know what region to shade. So I'm going to pick a point anywhere over here or over here, but I don't want it on the line. So I can just randomly pick a point. Let's pick this one right here. That point is 2, 1. X is 2, Y is 1. So when I come down here, I'm going to plug it into Y is less than negative 4x minus 1. And I know Y is a 1. Negative 4, X is a 2, minus 1. So let's see, 1 is less than negative 8 minus 1. 1 is less than negative 9. Is negative 9 greater than 1? No, it's not true. So I would not want to shade that region. I would want to shade the other region. And any point that I select over here, it would make the inequality true. Let's just test it out. Let's pick negative 3, 0. If I pick negative 3, 0, I'd say, okay, y is 0, less than negative 4, x is negative 3, minus 1. I got 0 is less than a negative times a negative is a positive. 0 is less than 11. Is 11 greater than 0? Yes, it's true. Any point you would pick over here would make it true. Okay, let's do another example. This one is in standard form. Now, you have two choices here. You could put it in slope-intercept form, or I could find the two intercepts where it crosses the y and the x. And I think I'll do that. Okay. But let's first, step one is to find out, oh, we forgot the sign on that one. Okay, if it's less than or equal to, then it would be a solid line. Okay, step two, I am going to graph 2x plus y equals 7. Just going to ignore the inequality. Okay, I'm going to set x equal to 0. And solve for y. 0 plus y equals 7. Well, that's pretty easy. Okay, now I'm going to set y equal to 0. And I'm going to say 2x plus 0 equals 7. 2x equals 7. X equals 7 over 2, which is 3 halves. I'm okay with that. 3 halves. Now I can go plot those points. 0, 7 is way up here. And then I have 3, 5, 0. Okay, that would be my line. And it's a solid line because it's less than or equal to, so I'd get my straight edge out and I would draw my line in. And as you can see, I'm not very good at drawing the line in. Let's try it again. In fact, why don't I just try a little line maker for me? Then it snaps it to where it's supposed to be. Makes it really nice. There we go. Okay, there's my line. Now I have to decide what region to shade. Okay, so I'm going to randomly select any point I want, and I'm going to pick 0, 0, because that's pretty easy. And I'm going to come over here, I'm going to say 2 times 0 plus 0 is less than or equal to 7. That's putting 0, 0 in my original equation. So I'm going to say 0 plus 0 is less than or equal to 7. 0 is is 0 less than or equal to 7? It's true. So I'm going to shade everybody over here. Okay. Let's do one more example. On the test, we had a problem because I gave them a graph, I gave them this equation, and people had forgotten how to graph horizontal or vertical lines. So the first thing, there's a little that's greater than or equal to, so it's going to be a solid line. Oh, let me get my pen. It's going to be a solid line. And I'm going to just graph the line y equals 2. Now y equals 2 happens to be a horizontal line right there. Isn't y equal, no matter what I pick for x, y is always equal to 2. Okay, now I'm going to go and check a point. So I think I'll pick 0, 0, because that's the easiest one. So if I put, now I don't have to put it in for x, but if I put a 0 in for y, is 0 greater than or equal to 2? Not true. So I know that I'm going to shade everything above the line. And if I picked any point up here in the shaded area, it would make it true. Okay, let's try one. I think that's the last.